Hello and welcome to our today's video on electrical. Today we will discuss the difference between AC and DC electricity. Electricity is an essential part of our daily lives, and it's important to understand the difference between the two main types of electrical power: alternating power AC and direct current DC. In this video, we'll be exploring how it was discovered, the difference of each type, the pros and cons, and when and why one type might be preferred over the other. Direct current, or DC, is the type of electricity that is generated by batteries and other sources like solar panels. DC power is characterized by constant voltage and a flow of electrons in one direction. This type of power is well suited for certain applications like charging batteries or powering small electronics like cell phones. Alternating current, or AC, is the type of electricity that is generated by power stations and distributed to homes and businesses through the electrical grid. AC power is characterized by a constantly changing voltage and direction of current. This type of power is preferred for large-scale electrical distribution because it can be transmitted over long distances with minimal loss in energy. Let's use Proto software to see the difference between two signals, one of the DC source connected to channel A and two an AC source connected to channel D. When we run the simulation on the digital oscilloscope, we can see these results. The yellow is the DC source, and we can see it is a straight line no matter what. The green signal is the signal of the AC source, which goes up and down, plus and minus, plus to the peak and minus to the peak. And please note that both of them have the same magnitude, a 20 volt magnitude. And that's the difference between two sources: DC, which goes on a straight line, and AC, which goes up and down, passing through zero. Let's watch a video demonstrating how the electricity is distributed to our homes. As we can see, now these are power plants that generate electricity, hydroelectric power, PV solar system, and wind turbines that all generate electricity. First, the power starts with being a high voltage power, mainly between 33 kV to 220 kV. Then it is transformed to low voltages by a transformer. And please note that transformers will be discussed later in the channel. How direct current was invented. Direct current was produced in 1800 by Italian physicist Alessandro Volta's battery. Back then, the nature of how current flowed was not yet understood. Then, Thomas Edison came and worked on developing the direct current. And note that direct current, DC, back then was the standard in the US. That's Thomas Edison. Now, about alternating current. The story of alternating current is the story of the evolution of electrical power distribution. AC was not invented by a single person, but rather was the result of the work of several inventors and engineers in the late 19th century. Some of the key figures in the development of AC include Nikola Tesla, George Westinghouse, and Michael Faraday. The story behind the war of currents. AC current quickly became popular for large-scale electrical distribution and was adopted by many countries as the standard for electrical power. This led to a war of currents between AC and DC, thus between Tesla and Edison, as different interests sought to promote their preferred type of electrical power. Today, AC remains the standard for electrical power distribution and continues to play an important role in powering homes, businesses, and industries around the world. Advantages and disadvantages. One of the main advantages of AC power is that it can be easily transformed into different voltages and frequencies, making it easier to distribute over long distances. Also, AC power is more efficient for high power applications like motors and lighting. However, one of the disadvantages of AC power is that it can be dangerous to work with because it can generate dangerous high voltage arcs and sparks. Now, let's watch this video to know why it is dangerous to work with high voltage AC power. DC power, on the other hand, is safer to work with because it doesn't generate dangerous arcs or sparks. DC power is also more efficient for certain applications like charging a batteries or powering small electronics, etc. However, one of the disadvantages of DC power is that it can be less efficient than AC power for high power applications, and it can be more difficult to transmit over long distances because it can be easily transformed into different voltages and frequencies. So, which type of electricity is better, AC or DC? The answer is that it depends on the specific applications. AC power is preferred for large-scale electrical distribution, while DC power is preferred for certain applications like charging batteries or powering small electronics. That's a brief overview of the pros and cons of AC versus DC electricity. Whether you're an electrical engineer, a student, or simply interested in how electricity works, it's important to understand the differences between these two types of power. Thanks for watching, and we hope you found this video informative and helpful. And if yes, please subscribe.